Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome to Geeks for Geeks. Today, we would be discussing the GFG Weekly Coding Contest 96. So, this would be a post contest analysis session. So, before we move forward, I'm Siddharth Hazra. So, basically, I would be the person who is entitled to give this post contest analysis. And I'm already acquainted with the problem, with the third problem. Okay, so can I have a quick one in the chat if you are present? So I would just know what are the other people that is there. Okay, fair enough. So let me tell you my views over the contest. The first problem was a easy level problem. The next problem was a variation of a standard, like very standard algorithm, like the binary search algorithm, and we got it. The third problem is wrong. How and why it is wrong, you only tell me. Why? And there are two things that you need to do from my side, my request, if you want this contest to get better. The very first thing is you mention the problem in the question, in the chat itself, so that I would be able to take an account of what is wrong. The very next thing that you need to do is if you're watching this stream in the recorded version, tell me the points where it is wrong so that this would be forwarded to the team of the problem setters of Geeks for Geeks itself. Okay, so let's start now. The very first problem, which is the maximize sum. Okay, let me just share my screen. Okay, fair enough. So see, in this one, we are given an array of size n, and we have to construct an array of size b, where bi is equals to I into ai. Suppose this is 1, 2, 3, 4, and it is one indexed. So it would be one, like let's make the number a little bit weird. So this is the array elements. Let's say it is 2, 3, 5, 1. These are the array element, and this is the indexing. So basically what you need to do is 2 multiplied by 1 is equals to 2, 3 multiplied by 2 is equals to 6, 5 multiplied by 3 is equals to 15, 4 multiplied by 1 is equals to 4. So we need to add up this value and we need to increase up this value. Okay. And we are allowed to rearrange the elements n multiplied by n times. This just simply means that we can rearrange the element in either way as possible. Okay, and we need to find the maximum sum out of that. So now let me just cater the sample test case. So if I'm given the sample test case, then what I can do is I can keep here 1 and I can keep here 2. So the sum would be 1 multiplied by 1 is equals to 1 and 2 multiplied by 2 is equals to 4. That is why the sum is 5. This is how. Okay, fair enough. Do I make sense? Give me a quick one if this test case is clear. Sample test case is clear or not. So for the third problem, what are the issues you had? Just quickly tell me. Quickly tell me the issues you have for the third problem, and I would forward it to the team itself. Just quickly tell me. Okay, let me just turn on the screen. Okay, so Shoshant, this is not clear. So in this problem, Yes, what is the issue with the third problem? So, for this problem, am I visible? Yes, I'm visible. For the third problem, it is that what we need to do is we need to reorder the elements. So, given an array, so the statement can be given an array, reorder it, reorder it so that ai multiplied by I is sums to a large value, sums to the maximum value. Okay. So if the given array is 2 1, so in the given sample test we have 2 1. So what we can do is we can simply just reorder it to 1 2 and the indexing are 1 2. So the sum 1 multiplied by 1 is 1 and 2 multiplied by 2 is 4. That is how the output 4 is popping up. Output 5 is popping up. 1 plus 4 is equals to 5. That is how the output 5 is popping up. Okay. Fair enough. So am I clear, Sushant? Am I clear with you? Just can I have a quick yes or no from your sides? So I would move forward because I think that it is resolved. So now if you see, we have the consecutive indices. Okay, we have the consecutive indices. Now, if a large number is multiplied by a large number, then it is more beneficial than large number multiplied by a small number. So which is beneficial? Let's say that we have here large number and a small number. Okay. And here also we have a large number and a small number. So and the sum, consecutive sum should be greater. So if we multiply the large number with a large number and the small number with a small number, then this would be more beneficial. Suppose we have, for example, if we have 5 and 3, and this is, let's say, 4 and 2. So the sum of this would be 5 plus 4, that is 20, 3 plus 2, that is 6, that is 26. Okay, one value is 26. Now let's say we have 5 and 3 and this is 2 and 4. So this value would be 10 plus 12, that is 22. So by doing this we can see that multiplying a large value with a large value is more beneficial. So what we can do is we are given the array elements, and if we just sort it, then the large value would lie at the end and the small values would be lying in the front, and that would be the most ideal thing to do. Okay, so idea is that we know that large indices lie at the end, so we need to put the large elements towards the end. So what we can do is we can simply sort out the array so that the smallest number is in the front and the largest number is in the back. In the same manner, the smallest index is in the front also, the largest index is at the back. ओके, ट्रांसलेटिंग द सेम इन हिंदी वुड भी, हमें पता है कि एक बड़े वैल्यू को बड़े के साथ मल्टीप्लाई करने से उसकी वैल्यू ज्यादा बेटर होती है बड़े वैल्यू को छोटे वैल्यू से मल्टीप्लाई और छोटे वैल्यू को बड़े से करने से। बड़े वैल्यू को बड़े से करो सो दैट द आउटपुट वुड बी वेरी लार्ज। ओके, अगर यहाँ पे दिया रहता टू मिनिमाइज द वैल्यू वी वुड हैव मल्टीप्लाइड द लार्ज वैल्यू विद द स्मॉलेस्ट वैल्यू so that its effect is more small. Okay, so we can just simply sort it, multiply the consecutive indices, and then just return the result. This is how the output of this would be. Hi Mrityunjay, so let me just code it at least. Okay, so I would make this as lowercase a. Okay, and this is done. Now what I would do is I would simply sort a dot begin comma a dot end. After this is done, we would have a long answer is equals to 0 because so that it doesn't have a garbage value. Now what we need to do is we need to simply iterate. for int I is equals to 0, I is less than n, and I plus plus. But as you can see, the indexing is from 1, but in real in array, the indexing is for 0. So I would say that the indexing is I plus 1. Okay. So I would say answer is equals to answer plus equals to a of I, okay, a of I multiplied by I plus 1, because the indices, see here, the indices are 1 indexed. That is why we are adding plus 1 here. Okay, at the end, simply return the result. Okay, now let us submit this and see how many errors are we making. So long answer, sorted it, then for int I is equals to 0. Okay, we need to typecast it. Long temporary variable is equal to a of I. Now this would work. We just need to typecast it, because adding an integer every time is multiplying, the resultant value is an integer. This would be there. Why? Because see, this is a very small thing but a very important thing. See, earlier a of I is given in the form of integer. So the resultant value of a of I multiplied by I plus 1 is also an integer. That is why if the value is more than integer, it would give wrong output. That is why we are typecasting it to long and then we are giving the output. Else what you can do is you can have a of I and then just do long. Now let us submit this and see. Okay, it is not getting typecasted, so this would be here also. Long. Yes, this is correct. Now we can just remove this. Even without this is clear, but see, this is the issue that we were facing. See, one of them is long, so the output is also long. That is why we were getting a wrong answer. Now, do I make sense? I would just preview the now this is minimize sum, this is maximize sum, sorry, not minimize sum. Okay, now tell me the line number at which you are not able to understand. First was very easy, second question is not very clear. No, it is clear. Could you simply just multiply element and number? Yes, done. It's done. This thing is done. So tell me the line number at which you are not able to understand. If you are able to understand, give me a 0. Give me a 1 in the chat. And please like the video so that the reach of this video could be increased and this work could be justified. Thanks a lot, Matam. Thanks a lot, Sujendru Pal. I think we can move forward. No one is asking any issues. Entire screen and it's done. By the way, a small feedback, because at this point of time, so by the way, I had a stream on 1st of January, and there I said that I won't shave now, I would have a full beard or kind of thing. So now tell me if this beard is suiting me, or should I switch back to the same trimmed look or a chiseled look. Okay, so I think I can move forward. So minimize computer. This is the question I like very much. Like when I read this type of question, I get a hint, to be honest. Okay, so now see. Yup, this is done. So now see, this problem is that there are n students given by the array A, and all the students are there in a queue. So let's just draw something. There are n students standing in a queue, and now they are telling that geek has k amount of time. So the amount of time, the duration of time, this is what? Duration of examination. Okay, this is the duration of examination. And this is the amount of time, and he has set up x number of computers. So that means if the value of x is equal to 2, then there would be 2 lines. Okay, sorry, why is this happening? Okay, so now suppose this is a counter. Okay, this is a counter kind of thing. This is a counter kind of thing. So if this person would complete the examination, then this person would pop in. This person would also complete, this person would pop in. And same would happen for the next row also. So basically, the number of computers are the number of counters, and all the people are there to take up a ticket. And what is the array value? Array value is the time required for you to buy the ticket. Okay, कुछ लोग टिकट लेने आए हैं, टिकट काउंटर x ड्यूरेशन तक ही, टिकट काउंटर k ड्यूरेशन ऑफ टाइम तक ही खुला रहेगा, और x क्या है? x is the number of ticket counters. Okay, this is what happened. और array value क्या है? Array value is the time for each people to buy the ticket. Just replace the whole problem statement with this scenario. Okay, first tell me if this scenario makes sense to you or not. Am I clear with the problem statement or not? And this problem statement is absolutely correct, and it is very true. There is a mistake in Geeks for Geeks, I would accept, but this is not a mistake. I have just interpreted each of the problem statement into a real life scenario, and they seemed correct. So now tell me if the problem statement is clear to you or not. Second question, ask this question in your Insta story. I don't have much followers in Insta. My Insta is just, I think, 1 year old. When I bought my bike, that time I thought that yes, I need to open an Insta. Okay, can you explain briefly once again? See, sure. See, ticket, the ticket counter would be open for k duration. Okay, x is the number of ticket counters, and at each ticket counter, each person would take ai amount of time to buy the ticket. This is what is there, and what you need to do, you need to tell the minimum 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 ticket counters needed to complete less than equal to k duration. This is the question itself. This is the visual representation and a real life scenario interpreted from the problem statement. Okay, fair enough? Do I make sense? Where can I find code? So now am I clear? Metham and Ayush, am I clear? Just quickly tell me. Metham, just quickly tell me. Where can I find code? Which code do you want? You want the code of the editorial, or you want the code of mine? What do you want? Okay, done. Chalo. Okay. Ab. Minimum ticket counters needed to complete less than k duration. Okay. So now the most basic idea would be that let's first explain you the sample test. Let me first explain you. So suppose there are two ticket counters. Okay, there are two ticket counters. Okay, let's take a snapshot of this. So let's say that there are two ticket counters. The very first one is C ticket counter 1 and ticket counter 2. So first, this person comes here, this person comes here, and this person comes here. Then this person, after time t1, this person would go out, and this person still requires 1 unit of time. 1 unit of time has passed, and this person has finished 1 unit, and this person required 1 unit, so 1 unit is now gone. Now this queue is empty, so this person would now come here. Okay. Now one more unit has passed, and this ticket is done, and it would require one more unit of time. This is time 2. Okay. Now this would come into picture, and both of them would be done in time frame 2. Okay. This is how you can do the problem in this. Okay. So the counting starts from 0 and ends at 2. The counting starts from 0. Please remember it. Why? How I told you that counting starts from 0. It doesn't mean that I know the problem set is. It just means that I'm good at observation. See here, at time 0, he can admit X number of students at time 0. Okay, so the counting starts from 0 itself. Third question, Sarji. Third question today we would skip most probably. Okay. Okay. Fair enough. So now see, this is how the output of 2 is popping up. So now what I can do is I can simply code up for one compute. I can I can just set up one counter and see how much time is required. Then I can set up the second counter, and then I would again see if it is feasible or not. Then I would set up the third counter, and again I would see if it is feasible or not. And the first point, okay, and the first point where it would be feasible, I would say that is the answer. So I can say that for I would check for first counter, then I would check for second counter, then I would check for third counter, then fourth counter, then fifth counter, then sixth, then seventh. I would go till the last, till the point I reach the first. So suppose the minimum answer is 4. So I would go for 1. This is not possible. I would go for 2. So I would go for 1, and it is false. I would go for 2, it is again false. I would go for 4, it is again false, and at 4 I hit the true point, and I would say this is my answer. And for 5 also it will be true, for 3 also it would be true. Suppose what I want to say is, agar if the same work can be done, like suppose setting up two counters, after setting up two counters I require 2 hours. So if I set up 3 counters, it would require less than 2 hours. If I set up 4 counters, it would require less than 2 hours. Okay, so setting up more counter is always better. So I just need to find the point where it is true. Okay, so I need to take hold of this point, the first point where it is true. So now let us simply first see if it is done or not. So now to see this, what I can do is I can simply use a technique. So how to check if it is feasible or not? To check if it is feasible or not, what I can do is first I would insert 2 zeros. Okay. And then the first point where the queue is empty, I would replace it with a new element. Then again, I would go to the next smallest element. So I would find the smallest element, replace it with the current element. Then again, I would remove, and again, I would keep adding that value in the answer. So finding the smallest element at each point, and I keep pushing elements. So my requirement is finding minimum at each step. I want the minimum at each step. Then the very next thing is I want to insert elements. And suppose I want to remove, because suppose this person is done with the ticketing, so I need to remove also, and I need to insert also, so I need to remove elements also. Remove element, and that would be mostly the minimum one. Okay, so I want to find the minimum element, I want to insert the minimum element, I want to remove the element. Okay, I want to insert new element, finding the minimum at each step. So the answer, one stop destination for this one is priority queue. So I would simply define a priority queue of min heap. Of what? Min heap. Okay, translating the same in Hindi would be, first I would start each counter at time 0. Then I would take up a new value. If this counter is empty, I would add that time in my timestamp, and then I would insert the new value. Okay. Then in the second counter, I would take up this minimum, then I would keep doing that. Find out the minimum value, add the timestamp to my result, and then I would remove it. At the end, if the timestamp is less than equal to k, then it is feasible, else it is not feasible. Let me just implement this part. Okay. So what I need to do is, I can just do something like this. Bull check if it is true or not. Okay. So here I would have the original vector array, vector int and a. So am I visible? Okay, telling you. First I have the given array, then I have the number of elements which can also be taken out. So I would just have int a, then int n. N is already given here. So I would just take the input from here. I don't need to take a dot size. A dot size would also work. Then I would say k is the amount of time we have, and then I would say this is the number of counters. Number of counters is equals to c. Okay, I would do that. Now first I would initialize all the counter with 0 at time t is equals to 0. So I would make 5 counters, and I would have 5 number of c counters, and I would initialize each one of them with 0. So I would say for int I is equals to 0, I is less than c and I plus plus, and then pq dot push the value 0. First, initially all the counter is empty, and then I would initialize a priority queue, priority queue, and then it would be int comma vector. So I need a min heap of priority queue, so it would be greater of int and then pq. If you are not able to remember this long syntax, this is basically min heap. Okay, so I can simply say priority queue c plus plus. Okay, this is priority queue c plus plus, and I have simply copied this line. Okay, I have simply copied up this line. This line is same as this one. Okay, this line is same as this one. Okay, okay, see, same thing. Okay, I have copied it from here. If you're not able to remember it, what you can do is you can simply multiply the value with -1 before inserting. After taking out, multiply the value with -1 again. So max heap would be converted to min heap, and you don't need to remember this long syntax if you don't remember. Now I would say initially the max counter we have is 0. Initially everything is 0. I require a time of 0. Every counter is empty. Now I would start processing the people. So now I would say for auto x of a. Okay. So first I would find this counter with the least busiest person. That is t is equals to pq dot top. pq dot top would tell me the minimum element. Okay, then I would remove the minimum element. PQ dot pop. I would remove the minimum counter because I would insert a new one. And then I would say T plus is equals to X, the new value. Okay. And then insert it again. Okay. So suppose the counter was 0 and then a person of time 2 came. So 0 plus 2, that is the time required. Then I suppose 2, then again a new person came of time 4. So 2 plus 4, that is 6. So basically we are doing that. Previous value plus the current value. Okay. Now if the time, new time is more than, okay, if the new time is more than mx. Okay. So if the new time is more, let's say mx because max is already a reserved keyword. So if the new time is more than mx, then max is equal to t. Okay, so what I can simply do is mx is equal to max of t comma mx, and this would be the same thing. Now I would say if mx becomes at any point becomes more than k, then I would return false from this position only. Like suppose we know that the ticket counter would be open for 3 hours, but now we know that it is past 3, so there is no point in moving forward with the ticket counters. This idea is not feasible. That is why if at any point we exceed the given limit, we would say no, this arrangement is not possible. At the end we would simply return mx is less than equal to k. If mx is less than equal to k, it would return true. If mx is not less than greater than k, it would return a false value, and this is done. Okay, and now we can simply do a for loop of one, like we can simply do a for loop from 1 till the value, and the first point where it is becoming true, we would return that. Do I make sense till this point? So I would just share the screen. Tell me the line number at which you are not able to understand. So minimize computers, and this is. So tell me the line number where you are not able to understand. Okay, just tell me the line number till this point. So long sum is equals to 0, for int I is equals to 0, sum plus equals to, and int sum is equals to sum by k plus return num. Sum divided by it within the bracket k plus 1. Give me a quick one if this thing is done. GQ, have I written GQ dot push? GQ dot push 0. Let me just see. Have I written PQ? Okay, PQ. Okay, sorry. Thanks a lot. The definition I have, like, now do I make sense to you? Mohit, do I make sense to you? Line number 37. Line number 37, line number 43. Line number 37 is this. So first we are initializing the number of counters. So see, initially the priority queue is empty, but initially we need to make counters. Suppose I have initialized, let's this would disturb. So suppose I have initialized, so I said that I allow 4 counters. So initially I would initialize the first counter. Let me just write it in the bottom, or let me write it on the top. Yeah. So see, initially I would say that this is the first counter, this is the second counter, this is the third counter, this is the fourth counter. And we would only edit all this so that the number of computer is respected. If we don't insert 0, then we won't be able to keep a track. So we are making every counter as 0. And if you observe, here we are popping element, here we are again pushing element. So number of element is not changing in the priority queue. Number of element in the priority queue is equal to C. That is why inserting 0 in the priority queue is absolutely very necessary. Why? Because let's say that this becomes 2. So now 0 would come in at the top element. 0 would pop as the top element. This is why we are inserting 0. Okay. So what is the value of x? What is value of x is the elements. X is a of I. X is a of I here. Okay, this is done. Line number 43. What is line number 43? T plus x. Okay. Suppose the earlier person, let's say every counter is filled with 2. Okay. Now suppose a new person came and he would require 4 amount of time. So from 2 I would add 4. 2 plus 4 is equals to 6. So the time required by the first counter becomes 6. Time required by the first counter becomes 6. Now, this is why we are doing that. That is why we are adding the current time to the counter. This is what we are doing. Anything more? Am I clear, Manik Saha? Am I clear, Sarthak Chaudhary? Can we do dry run for it? Yes, absolutely. Let's do a dry run. Let's say the number of computers are. Okay, let me just present my screen. I would do a dry run also. Whatever you say, I would do it. Let's see how many likes I can get by doing this. Okay. So this adds to a new page. And this was it now. Okay. So first we are inserting 0 in the priority queue. So this is the given priority queue. Okay. First we are inserting 0 in the priority queue. So first we are inserting 0 in the priority queue. This is what we are doing. Right? Let's say the value of C here is equals to 2. And k's value is equals to 5. And this array is the same array. So first mx, the value of mx is equals to 0. Okay. First we are taking hold of the smallest element. pq.top is equals to 0. So first we would take out this 0. We would assign it to the value t. Assign it to a value t, then we are removing it. Now t plus equals to x. So 0 plus 2 is equals to 2. Okay. And then we are inserting 2. So now as 2 is more than 0, so now 0 would be above and 2 would come here. And now again this is done. Okay. Now t is, now 2 is greater than mx. So it is greater. mx is not greater than k, so this won't return 0. Now we come to the second element, that is 1. Now 0 would first come and be assigned to t, and then it is removed from the queue. Then we add 1 to it. Okay. Then we see if mx is greater than, if t is greater than mx, we would update it, but it is not greater, 1 is not greater than 2. And then we would insert the new number, that is 1. Okay. And then we would remove this. Okay. Done. Then we come across again the value of 2. Okay. So first we would pop out this 1, take it here. Okay. Take it here. And then we add the value of 2 here. So 1 plus 2 is equals to 3. Now 3 is more than mx, so this one would get updated. After this would get updated, 2 would come on top and 3 would come at the bottom. Because this is a sorted array. This is done. Still 3 is less than 5. So this is still feasible. We are not returning 0. Then we come across 1. We take out the smallest element from the priority queue, remove it from the priority queue, then we add 1 to it, which makes it 3. So now 3 is not greater than mx, so we won't update it, and then we would insert it. So the maximum amount of time required was 3 and the permitted amount of time was 5. So yes, by using two counters, I can say that this is feasible. Now do I make sense? This is how this is working. So it will be pushed pq dot push not x. Please rectify. Pq dot push. Okay, yeah, new t. Yeah, we need to insert new t. Yeah. So I was explaining t, but I'm writing x. Okay. So now do I make sense? Why are we pushing x instead? No, I was pushing t, but I was saying that I am inserting x at the end. Sorry about that. Okay, in the explanation also I did push t in push t, but still I was doing that. So now, if you observe, the time complexity of this approach is big O of n, big O of n multiplied by big O of log n, because the operation of which is n log n. So time complexity is n log n. Why? Because each operation of the priority queue is this. So n log c this would be. Why? Because there are only c elements. So at each point we are doing one operation. So this can be thought of that we can just doing n log n. Okay. So now if you observe that if you use a for loop, you would get a time limit exceeded. Why? Because 10 to the power 9 multiplied by n log n is more than 10 to the power 8. So this would definitely give me a time limit exceeded. Okay. I need to think of something better. Okay. So now as you can observe that this type of function, where is that? Yes. This false, true is a monotonous function. Is a monotonic function. And whenever we have the answer in the form of monotonic function and we need to find the first position of false or the last position of false or the first position of true or the last position of true, it's a clear indication that this question is of binary search, where if we hit a true value, then we would need to go on the left hand side. If we hit a false value, we would need to go on the right hand side. So what would be the kind of equation? Let me just make this. Yep, done. What would be the kind of equation? No, this is. Can I shift this? Yep. Yep, screen is shared now. Okay, so this type of a function where we have false, true, and we need to find the first position of true or we need to find the last position of true, this is a clear indication that this is a binary search. Now, the equation is in the form of false, true, true, true. So, if the check function returns me a false value, then I need to go on the right hand side. I need to go on the right hand side because I know that if we move on higher number of counters, it would be feasible. So if suppose I am using 3 counter and it is not feasible, this just means that I need to increase the number of counters. So if this value was L and this value was low and this value was high, and suppose this value is mid, so if suppose this mid is not possible, that means I need to make L go to mid -1. So this just means I need to go on the right hand side, which just means that I would make L is equals to mid plus 1. Okay. Now if the answer is a true value, sorry, if the answer is a true value, if the answer is a true value, let's say this is low and this is, we are at the true value mid. So if we are hitting a true value, we need to find the first occurrence of true. Okay. Suppose I, with 10 counters, I am able to accommodate all the people. So now next time I would try with 9 counters because I want the minimum number of counters. So what I would do is I would make this H go here. Okay. So this just means that I need to move on the left hand side, which is equal to H is equal to mid minus 1. And here the last updated answer, so we would update answer at each point, and the last updated answer would be the first occurrence of true. Okay, now let us move to the implementation. I don't think much issue is there. What is the threshold for TLE? That is 10 to the power 8. For 1 second it is 10 to the power 8. For 2 seconds it is 10 to the power 8 multiplied by 2, and the number of seconds multiplied by 10 to the power 8. In 1 second we can perform 10 to the power 8 operation. Please remember this. Okay. Now I would say int low. Minimum number of counters required is 1, and the highest number of counters required is int, okay, 1e5 plus 1. Okay, let's say, let's just take a high value and we would initialize an answer. Okay, or you can just initialize here itself answer. Okay. Now we would say while low is less than equal to the high value, then we would say int mid is equal to low plus high divided by 2, and then we would say if check of ARR comma n comma k comma mid, if this is true value, then what we need to do, if this is a true value, this is a true value, high is equals to mid minus 1, and we would update the answer. We would say high is equals to mid minus 1, and we would update the answer also. So answer is equals to mid. Else in the other scenario, if the value is a false value, then we would say L is equals to mid plus 1. Low is equals to mid plus 1. Okay. At the end, the last updated answer would be our answer, and just now let us see how many errors I am making. Okay, okay, okay. Okay, to be honest, I'm also happy because binary search code. So sometimes if you make a small mistake in the check function, you mess up a lot. Like I was inserting here, someone noticed that this needs to be T. So now mention the line number where you are not able to understand. Stop the screen sharing, share the Chrome tab, and tell me the point at which you are there. So mention the line number at which you are not able to understand. So any issues from this side? So now tell me the errors that you have faced in the third question. So if you are done, give me a quick one. Now tell me the errors that you have faced in the third question. What was the problem basically? Can you quickly like the video? Quickly like the video. Let me check. Give me a quick one if you are done with this question. Else, just mention the line number at which you want an explanation. The number of likes is absolutely very less. It is not even equal to the number of live viewers. Can you quickly like the video at least, please? Can I quickly see the like counter going up? Now it is equal to 37. Two people liked it. I'm only able to influence two people at this point of time. Okay. And your code output, it's correct. Third problem's input and your code output is 2. This first case is incorrect. Let me just take a screenshot. Any other scenarios? Like what are the other issues that you have faced? Any the other issues than this? So I think this problem is done. So let's have a query regarding third problem. Query regarding the third problem. So you can quickly ask me. Not able to solve, was not able to, this test case is incorrect. Any other queries? Okay, so I would be skipping the third question. So multiply to, okay, seems fine. So fair enough. So first I would rectify, or can we return low 2 instead of answer at the end? Yes, absolutely. Low 2 at the end. If you return low 2 at the end, then if you return low 2 at the end, that is also fine. But I find it more intuitive if I know when to update the answer. Now, for the third question, I would have a talk with the problem setters tomorrow because it is now late night. I would have a talk with the problem setters. They would update it. Now, if needed, I would simply have an explicit explanation of the third problem. Explicit explanation of the third problem tomorrow itself. Okay, so the last minute queries. If you have any query, I would be waiting for the next 30 seconds and then I would turn off the stream. If you have any query, you can ask me, else I would just turn off the session. Sure, timing would be same at 8:30 around. Most welcome. So this time I thought that I should have a talk like this problem. Like people have invested some amount of time over the third problem and that shouldn't get wasted. That is why I think that I should rectify this thing and then I should stream again. In some of the binary search problems, low and answer gives different answer. I don't know how. Yeah, that is why many a times it happens with me also. That is why I prefer to use answer every time. Like if you see my submission over different platforms, you would see I prefer to use answer every time. Most welcome. So that was it from my side. If you are here till this point of time, consider waiting a bit more and commenting on the video so that the reach of this video could be increased. The same way you are criticizing the problem you are faced, you can appreciate the things which is right. So the right one would get pushed a little bit more. So you can appreciate the stream. And in the same way, you can have a positive criticism over me also, over at the team of Geeks also, so that we can get better. That's it for today. So if you're watching the stream in the recorded version, feel free to like and comment the video so that the reach of this video could be increased. Thank you everyone. Good night.